There will be a second video to this group where I point out some of the issues with working in the diameters and going through the lathe project, that it's real easy to get the numbers shifted and get yourself confused, which is exactly what I did. So I'm in 2018 because I also want to post this this code. So might have a little bit different look than the 2020 Mastercam. So our project, let's go ahead and pull this over for a refresher. Project is going to be starting at 1 inch and then ending up at 4.5. And so last time illustration was that if we drew the lines and offset and started with a rectangle, we would have our basic geometry, and that's a little bit easier to visualize. And what I wanted to show was that if we just draw the geometry straight out, that we need to be concerned with the XY, and we're going to be a little bit better to work in the plane. So this would be one of those in the DZ plane. And so if I go over to the machine and set for the lathe and into the default, that puts our coordinate system in our plane into the plus D and plus Z. Right, so if I go ahead and make that the coordinate system and the tool plane, then that'll put me in a little better position. So going back over to the wireframe, my line endpoints will be starting at the origin, and I'm telling this to go to a length of 1 inch. Right, so the center diameter 1.0, and this is going to be a vertical, and I didn't lock it, so we'll go 1 inch again, lock it into place, and then hit OK. Alright, so okay, what didn't I, oh, I didn't click. Alright, so click, 1 inch, okay. So when I pick this and we go to F4, my D is showing it as a diameter of 2 inches because we came off a total of 1 inch. So I need to give these values in the diametral. So we're going to bring this back to 1 to set for a diameter, and then I should see a radial length. And if we go back in, diameter of 1 inch, and then our 2D of 0.5. So that's giving me the desired result. So line, and we need to send that back to freeform and come out, and I'm going to be going to 2.5 inches, and let's go ahead and unlock that. So we get the box up, start typing. Had to, I think I'd unlock the length. So 2.5, and then a diameter. So need to double check that I'm doing, am I doing D and then Z or Z and then D? So right now I think I'm doing Z first, so let's verify that. So we're going to a 2 inch diameter, and get my numbers straight here. And, oh no, 2.5 in Z and 2 in what would be our X, or with our D value. So let's go ahead, and I did not put that in as a negative value going to the left. So let's go ahead and kick that off, and then back into F4 we'll double check our number. So we're going from 1 inch to 2.5. That should actually be 2. So I'm going to delete that out. And since I put the 2.5 inch first, I'm going to pick the number, and then I'm going to go 2, and that needs to be negative, and comma to a diameter of 2.5. Or sorry, diameter of 2. Now I've got my signs mixed up. So a diameter of 2 and a Z dimension of -2.5. So let's go ahead and see what that one looks like, and then we'll stop and verify. So F4. All right, so starting at a diameter of 1, finishing at a diameter of 2, and since we gave it a length, the Z -2.5, then the total length will be whatever we figure out for the hypotenuse of our triangle. So that corrects, verifies my geometry. And then I'm going to tell this to go to the endpoint, and we have again a diameter of 2 and comma minus 3.5 to get to our number. Okay, and then I'm going to pick up the next number, and we have a diameter of 2.5, and the z dimension will also be the negative 3.5, so I could set these vertical. Make sure I get the negative in there. Okay, and then we'll pick off of that side, and we're going to stay with the diameter of 2.5, and it is going to be to a negative 4.8. And then we'll pick up the endpoint. We're going vertical again, so this will pick up a diameter of 3.75, and we'll be at negative 4.8. Okay, and then the last geometry will start, and we are going to a diameter of 4.5, and we will end up at negative 5.175. Right, and then the last will be to go with a vertical line, and we'll bring that back to where it intersects the x-axis. And go ahead and accept. So in the other video, I drew this in the xy coordinates, and then when it shifted over, we saw the changes, and then I tried to modify it, so you can kind of fast forward through those, and you get the gist of some of the errors that can come up. So my radius is 0.5, and we're going to pick our pieces of geometry. Main thing is that you check and you verify as you go, and you can pick up those geometries. So distance of 0.03, and we'll go between, and that one still looks small to me, but there we go. So assume that a 0.03 is going to be an edge break on the radial, and what it kind of looks like in the picture is more along the lines of maybe a 60 thousandths. All right, so once we've picked up that geometry, we can go through our normal. So the files, just to double check, we have the lathe, we have the control, have the tool settings. Again, at some point I'm going to look back through the control definition and set these as defaults. And if we're using our material, then we can set and select our lathe library and accept. Oh, and I missed the stock setup, so let's go ahead and set the spindle and the properties. So if we're going 4.5 on our diameter, then our length will go to -7 or so, probably to 8. So 7 inches, and then we'll shift maybe 30 thousandths on the position along the x-axis. And we should see a preview so that it has that material to take for the facing operation, and then we're at the outside. Okay, and then when I set the properties for the chuck jaws, on the other one, notice that I stayed with this OD number 1, and that seemed a little bit big. I don't know that we will be at the diameter where we can go to OD number 2, but we'll probably be with OD number 3. So the consideration here is chuck jaws are at 4.5 inches, even on a 10-inch chuck, an 8-inch chuck definitely, but a 10-inch chuck, we're going to have quite a bit of this jaw sticking out, which is not very safe, helpful. All right, so diameter will be at 4.5, and then this one gets the negative. Let's go like -6 inches so we can see the clearance. And when I hit tab, I'm going to see that that preview. All right, so since it's at the material, Let's see what happens if I go to -7. All right, so you can see that it's holding onto the ID, and we're kind of relying on that engagement to hold all of this rotating mass and be able to clear when we do the operations. So go ahead and hit OK, and OK. All right, so our first operation will be the facing. WCS does not match. W is the stock plane. Okay. So we still have the D and Z. All right, so I messed with the WCS and I shouldn't have. All right, so we want the tool geometry. I'm going to slow down the feed rate for a facing operation. Let's go about 5,000 inch per revolution. We can always speed this back up, and we'll go up to about 400 surface feet. We talked a little bit about max spindle speed. Even a high-speed lathe is going to be about 6,000. I don't know many of 10,000. So if we were to set max spindle speed at 3,000 as it gets to the center, it would probably hit that. But again, we have the 4.5 inch by 6 or 7 inch long piece of stock. That's a lot of rotating mass to contend with. The home position of D and Z. And if I go to user defined, then we'll set the definition. I want to bring this back just a little bit. Usually the diameter, we're at 4.5, so if I maybe make it 6 inches, and in Z we just need enough to clear. We're going to be doing this operation a couple of times. So let's bring it back maybe 5 inches, and we'll go ahead and select. All right, and then the facing parameters, we have enough clearance, 100 thousandths, using the stock. And the finish step over, we're going to go to 0. Overcut amount, if we have again, an 8 thousandths or maybe a 16 thousandths nose radius, even a 30 thousandths nose radius, we're going to want to overrun this by probably 10 to 20 thousandths just to make sure that we get past the center point, that our center drill combinations pick that up. And then if we want a little more control over the lead out, we can activate and utilize the lead out 45 degrees and 100 thousandths before it retracts. Otherwise, it kind of just comes straight off, which is not a bad thing. Just a little bit difference on that. Bring it in, retract out, go away from the center line. All right, so the next one will be to set our roughing. And I haven't used the dynamic rough, so we took a look at that. We're looking at an operation and a future project that we can utilize that. So we're going to stay with the roughing. And then I'm going to pick my outside geometry, bring it to the end, and go ahead and hit OK. And apparently I did not update that WCS, so that is still going to be a little bit of an issue. For the roughing operation, 5 thousandths, plunge feed rate of 5 thousandths. We'll stay with the 400 surface feet per minute and give it the max of 2,000 since we're going to be removing a lot of that material. And for the roughing parameters, again, we'll want to think in if we're doing equal steps, and the depth of cut. I would want to measure at the machine is 100 thousandths taking a diametral, so 50 thousandths a side, or is it taking a radial, which would be the 100 thousandths per side, or a total of 200 thousandths off of the diameter. So once we've determined that, we'll take a little bit more, but I think initially I'll be comfortable with that total of taking 50 thousandths, and we get the part running, we see what it's capable of machining, then we'll make adjustments. So stock to leave in X is 10 thousandths, stock to leave in Y, Z is 10 thousandths, or stock to leave in what would be our diameter. And then for our direction, so we're bringing it in, so we have interior, we can start at the outside and feed in towards in the X direction, and then from the back, no. I think we're good letting it feed in, and we'll stay with the one-way cutting and zigzag. Straight or zigzag downward, we'll stay with the one-way. Having it retract and come back is usually going to be the safest. We'll check the lead in, lead out, so 180 degrees, starting 100 thousandths off the end of the part, and the lead out 45 degrees, 100 thousandths back to clear. And then the entry amount of 100 thousandths, I'll probably overrun it by 100 thousandths just to make sure that we get plenty clear. All right, so let's go ahead and see what that looks like. All right, so on the first one, we get that extra 100 thousandths. If there happens to be material out there, that makes sure it cleans up. And if we decide to do the parting cutoff tool, then we'll be able to pick up that geometry. All right, going into the finish, then I want to use the last. So the previous chain that we picked, we'll go ahead and select. And I do need to update that. For finish pass, we'll probably slow down to 2 thousandths per revolution. But I'll speed up since we have less rotating mass now. I'll probably speed up the spindle speed to try and get a little better surface finish. And we'll max at 3,000. Since we still haven't moved, shouldn't have to move to the home position when it retracts. So let's go ahead and set a user defined. We'll probably finish after this one. So I think we said 5 and 5 or 6 and 5. We'll go ahead and set. That'll update the home position, and then we'll go to the finish parameters. So a finish step over 100 thousandths, 1 pass, stock to leave in X, stock to leave in Y. Check our lead in, lead out, 180 degrees for 100 thousandths, and then 45 degrees for 100 thousandths to clear. Go ahead and accept. All right, so if I can't quite see that, we're going to go back and turn off the display for the facing. And we're calculating for the nose radius based on that tool, so it's going to be just inside of the profile that we're cutting, and notice that the stock is updating accordingly. All right, so when we go to set, and these will be the pictures that you see at the beginning of the next video. When we go to set for drill operation, we're going to pick, and let me go ahead and cancel that for a second. Let's double check. All right, so top WCS construction and tool plane on the D and Z. All right, let's see if that cures that problem. I won't do that again. We're going to go to the drill point, and if I select a library tool, then I'm going to want to open a folder. We have plenty of center drills in there. I'm going to forego that this time. We would probably put in a center drill, and then I want to pick for lathe, lathe center drills, lathe drills metric. So let's go ahead and see what we have in there. Want to show a drill in taps, so half 13 will be in the neighborhood of the 418 to 423, I think. So 421. That looks pretty good. All right, so we're going to go ahead and pick that one. That's going to bring us into the group. And again, because of that spacing, or because of what I previously loaded in the tool turret, the turning facing tool that I would most often use is probably going to be tool number 1. Tool number 2 would be a threading or a grooving tool. Tool number 3 would be either threading or tool grooving. And then I want to leave a space, so I will go up to tool number 5, and we'll make sure that it has the offset number 5. So when it designates this in the post, we'll see the T0505. And feed rate is in inches per minute, so let's go with go about 6 inches a minute. The 633 doesn't sound too bad. I'll max it at a little bit over so it doesn't overrun. And then the pec drill, we're going to give it a depth of, let's go -2 inches, since this really isn't called out. These are optional. -2 inches. The drill point is 0. Clearance we can set for additional for the drill point. And then the retract clearance plane of 0.25, retract of 100 thousandths. And then we want to see what this post has, but if I give the first pec like 500 and the subsequent plex at 1. Depending on the post, if we end up with that IJ and K value in our G83, then we can set the first PEC at 500, the reducing PECs at maybe 100 until it gets to 100,000. So, 500, 400, 300, 200, and then the rest to the 2-inch at 100. So, no custom parameters. We go ahead and see what we get, and we'll see the stock update. And then we're going to do the same thing for the tap. So we pick a library tool, going to open up the folder, make sure that we have the lathe taps and lathe taps metric if those show up in our mix. And I set a 1/2-13. So once we find 1/2-20, 1/2-13, we'll go ahead and accept it. And then we're going to set a spindle speed for 130, and that should give me a feed rate of 10. Oh, and I haven't set it at a tap yet, so once I set it to tap, that should override the feed rate. Well, did we select the tap? All right, so tapping feed. Well, really was expecting that to go to 10. And the 130, so that should override. Not sure what happened there, but let's go ahead and accept it. Tapping feed in, depth of -2. Assuming that we're going to have a spiral point tap, it's going to be pushing the chip ahead of the tap and into the part, so we're going to give it a little extra. Well, actually, we're going to leave the tap drill a little bit extra, so -1.5 on our tap depth. And then clearance of 0.25, retract of 100, and no custom parameters. We'll go ahead and accept. All right, so we don't see much difference in that. And so when I go back to my planes, we're in the WCS, and I haven't seen that error again. So we'll set to all 1. All right, so the cutoff tool, if we go ahead and set up for the cutoff, got to keep in mind that 4.5 inches is pretty deep, and I want to see how it generates this this code. So we have the cutoff boundary, and we need a library tool. So we're going to go back to groove turn face. I think we just want our default lathe inch. And the grooving tools, we'll probably go with a groove right hand, let's see, width of 0.25. Let's stay with the 1/8 inch. And then when that comes in, we said that this will probably end up being tool 2 if I didn't update the drills. I made 5, but I probably didn't make that one 6 or 7 to open up the spacing. So that one probably ended up being tool 2, so we'll make the threading tool 2 and leave this one 3. I'm okay with that. I'm just trying to match what's in the turret, and if we build our tool library correctly, then all I should be adding are the drills, tap drills that we need. All right, so max spindle speed, let's drop that down to 200. And if I set the RPM as a designated 200, feed rate of 2.5 thousandths of an inch per revolution, and that's still going to take a pretty big chip out of the part. Cutoff parameters, 100 thousandths. Let's see, where's our number? So from clearance into the part. And then incremental, we'll go 10 thousandths. And if I leave the X tangent point, we'll leave that up a little bit. I don't know that I want it to break completely off. With that much rotating mass, do we have a parts catcher? How am I going to manage this with that little bit of stock? Can I go ahead and take this over to the bandsaw and cut off that last little bit of material? Will the tool survive going 2 inches deep into the part? So a lot of questions related to this one. And we're cutting to the front of the radius, and depth-wise, yeah, we can probably adjust that in the control. I just wanted to see if there's a number. Oh, back face is stock. So if we go another 10 thousandths, that'll give us a little bit for cleanup. We'll have to check it against the operation, minus 90 degrees for the lead in, 90 degrees for the lead out. Okay, so let's go ahead and see what that does. And we're seeing just little separation, so there'll be some material. Notice that the tool holder plows into the stock. So we're going to come back over. And last time we adjusted on the insert length. I think we're going to go to the holder again and set our C value to 2 inches and see if that corrects for the geometry. Regenerate that dirty toolpath. I'll make sure that one of those selected. Now I was trying to get to update the stock, so let's go ahead and make sure it updates all. Alright, so if it doesn't update, then we're going to go back and pick all of them so that it has to recalculate all of the stock. So the drill and tap is optional, but there's usually going to be something somewhere we're going to have to contend with, so we'll go ahead and account for that.